On December 17, 2020, the Chang'e 5 lunar probe has successfully landed in China's Inner Mongolia area, bringing back 1,731 grams of lunar samples. It has been 44 years after human beings brought samples from the moon to Earth last time. These soil specimens are of vital importance to the study of the moon. In this video, I will briefly introduce the significance of the sample brought back by Chang'e 5 and the discoveries made by Chinese astronomers. Each of the discoveries has greatly expanded mankind's insight into space and has given scientists a glimpse of the evolution of the moon. Planets are alive, and the sign of their life is magma activity. Since magma activity stops, it means that the planet is dead. If the magma is the blood of a planet, then the flow of the moon's blood has stopped long ago. There has long been much debate in science community about when exactly the magma activity of the moon stopped, and the lunar soil brought back by Chang'e 5 provides a breakthrough in the answer to the question. When magma erupts and cools, it forms black basalt, which is the moon sea that can be seen from Earth. Basalt samples from moon projects of the United States and the Soviet Union provided evidence that the moon's magma activity lasted until about 2.8 to 3 billion years ago. However, this time, Chang'e 5 brought back the youngest lunar basalt to date and proved that the moon was still alive 2 billion years ago. This result is 800 million years earlier than previous results. The samples brought back by Chang'e 5 not only provide information on the lifetime of lunar magma activity, but also toss up many new scientific questions. For example, how did the moon's magma form? Since Chang'e 5 chose the landing site with the lowest impact crater density, it can be expected at the beginning of its mission that the youngest age of magma would be found. However, the characteristics of the magma source area that melted out these samples were not expected. A popular hypothesis about the moon is that the lunar volcanic activity is catalyzed by creep, which is a type of rock synthesis from uranium, thorium, potassium, and other elements. But a surprising fact is that no true creep was found from the samples returned from the moon by the Chang'e 5. From a long time, the creep component was considered to be the reason why the lunar volcanic activity continued for billions of years. After all, with only 1% of the mass of the Earth, the moon theoretically should have been completely solidified a long time ago. Chang'e 5's discovery implies that it is not the creep-rich lunar mantle that sustains the moon's long-term volcanic activity. In addition, Chang'e 5's basalt samples also reveals a very dry mantle of the moon. In all, it is sure that the return of Chang'e 5 will be a remarkable stroke in the history of human space exploration. The lunar soil Chang'e 5 brought back not only dramatically updated our existing knowledge of the moon's evolution, but also pointed a way for future scientific research. We can expect human beings to learn more about the mysteries of the moon and the universe in the future.